What's going on, everyone? My name is Johnny Bandon, and I will be your CCNA instructor for this CCNA video series. In this video, we're finally going to wrap up our lecture portion of straight layer 2 technologies. And our next videos, we're going over like ARP, interVLAN routing, which is layer 2 and 3. I like to call it layer 2.5, right? Starting to bridge the gap between our data link and our network layer, our frames and our packets. So let's make this the best lecture, right, of our last slides we're going to go over in section 3, layer 2. And we're going to go over a pretty important technology called Etherchannel, which is going to allow us to have a lot more bandwidth. And for the CCNA exam objectives, there's only a couple different Etherchannel methods or protocols that the CCNA wants you to know about. And that's going to be LSCP, PAGP, and then static Etherchannel. However, I want you to know, just for the sake of, real world, there is a lot of different types of Ether channels out there in the enterprise. We have something called VSS. We have Stackwise. I think it's called VPC, which is going to be on our Nexus OS. Another Cisco switch that you see a lot in data centers, right? Really bulky switches meant for data center builds. There's a lot of different Ether channels. The CCNA just wants you to learn about a couple different negotiation protocols and how it forms, because this is an enterprise level exam, meaning you're going to be working on that campus network, not necessarily data centers. You could be in your travels as a network engineer, but the CCNA wants us to learn about just layer 2, LACP, PAGP, and static. But you could also have layer 3 Ether channels. You can also do load balancing based off the layer 2 and layer 3 addresses. So Ether channel can be a lot more complex than what we're going to show you. And I just say that to have full transparency with the students that this is not the end all be all in Ether channel technology. When I was learning the CCNA 8 years ago and just starting out, I would watch the CCNA video and I'd be like, that's it. That's the Ether channel technology, just LACP. And then I go to my first data center build and they got Nexus OS switches on there doing an Ether channel I've never seen before. And I was like, whoa, what is this? And then I go to the next site and they got these Stackwise cables on the back of switches, creating a master and slave environment for for switches, right? So, and combining one control plane for multiple switches. So there's a lot more to Ether channel technologies than just what we're going to present to you on the CCNA. And if you're curious, please feel free to go check it out. And the reason I kind of want to go over this is because typically as a junior network administrator, you're working a lot in layer 2. So you're going to come across a lot of these different technologies more often than you may think, especially if you're working for like an MSP that has multiple different clients with multiple different network topologies and setups, right? And different vendors, maybe. But of course not. We love working with Cisco, right? So with that being said, let's go ahead and jump in because, again, we're here for the CCNA exam to pass it. So we're going to do a good job of describing the Ether channel technologies Cisco wants you to learn about here. So first, why Ether channel? Why do we need this link bundling technology? So Ether channel is just the term Cisco uses to describe what we call link bundling. Essentially taking physical interfaces and then combining all those physical interfaces into one logical link that is the sum of the total bandwidth of all these physical links here. So we can turn 2 gigabit links into a logical 2 gigabit link, right? So link bundling or Ether channel allows multiple physical interfaces to become one logical interface. So these bundled links appear as one interface and creates higher bandwidth between switches. So it creates higher bandwidth. It allows us more bandwidth. And I'm going to keep saying this because this doesn't necessarily affect our throughput. Because remember, underneath that logical interface is still 4 physical ports with a computer making a TCP stream connection to a server. That stream still has to physically go on one interface, which is physically still only a gig. Now, this does allow us to have other computers have that TCP stream on another link, but the throughput of one individual TCP stream is still capped at a gig. However, the bandwidth available to all users and all data traffic would be 4 gigabytes in this example here, okay? So just a common misconception that I want people to know, that if I have one computer here, and they're trying to do file transfers, you ain't gonna get 4 gigs on that a singular file transfer. Okay, and then link bundling terms. So we have some link bundling terms here that you may see out there in the wild. Link aggregation, port channel, port bundling, NIC teaming, and Etherchannel. Whew. So NIC teaming you're going to see a lot in like our server farms and server environments. Port bundling, port channel, you'll see in networking. And link aggregation, you see just in IT in general, people using that term. And then another term here I want you to know is something called member interfaces. It's an Etherchannel vocabulary or vernacular that describes the physical interfaces that bundle to become that Etherchannel. We call those member ports or member interfaces. And the reason I'm using the exact vocabulary is because on the exam, I want you to understand what these words mean, right? If I say member interface, I'm talking about the individual physical interfaces that make up that logical Etherchannel or port channel. And then a little side note with port channel. Even though Cisco calls their link bundling technology Etherchannel, when that Etherchannel is created, it actually creates a port channel interface. Okay, now let's go over some Etherchannel benefits that we can have. So we just went over the bundling terms, went over the vernacular that we have to learn, right, when going over Etherchannel. But now let's learn just some benefits that we could do. So we could load balance between our switches, either using layer 2 or layer 3 addresses, meaning we could load balance based off either the source MAC or destination MAC, or the source IP and destination IP. And then bandwidth. Like we discussed earlier, Etherchannel will increase your bandwidth between devices. However, it cannot increase or improve throughput on individual streams of data. And then we have the different Etherchannel modes. And I put a little parentheses CCNA because these are the Etherchannel modes the CCNA exam wants you to know about. So the first one we're going to cover is LACP. And this is the one they're going to test you on a lot. And I believe it's the only one actually in the exam objectives. But I've heard from students in the past that you still need to know about the other two, PAGP and static. But they deep dive more into LACP on the exam. So this is the IEEE standard Etherchannel negotiation protocol, meaning, again, vendor neutral. It's not Cisco proprietary. So any switch vendor or server really can use LACP to negotiate the formation of a Etherchannel or port channel. And then we have PAGP. This is the port aggregation grouping protocol. This is Cisco proprietary, and this also performs negotiation. And then, of course, we have static, which doesn't use any sort of protocol. It just says, hey, you're going to be an Etherchannel. Bundle your member interfaces up and form that Etherchannel. So then we have two different actual modes within the individual mode that we're going to talk about. So with PAGP, we have desirable and auto. When you place member interfaces into PAGP desirable mode, they're going to actively send negotiations out, meaning they're actively asking the other side if they will participate in the Etherchannel formation or in that channel group. Because when we form a channel group, we also have a number that both sides must conform to. So you can see here, if both sides are desirable on PAGP, they will form. If one side's desirable, one side's auto, they'll form. But if both sides are auto, they will not form. Because PAGP auto mode is going to passively wait for the other side to send that negotiation. And then, of course, these modes do not mix either. So if both sides are auto, they're just like never going to talk to each other, right? They're never going to form that Etherchannel because negotiation messages will never be sent across. And then LACP, we're going to have the same thing. But before we get there, just look at a PAGP configuration. So if we look here, how you build or configure an Etherchannel is the same way. The only thing that really changes is the mode. So here we go interface range to configure the interface we want to bundle into an Etherchannel. And then the command is channel group, a number, I think 0 through 255, and then you choose the mode. So here, this is choosing PAGP, and we're choosing to have switch 1's member interfaces send the negotiations. And then as you see here, after we execute that command, it's going to actually create that port channel and have that port channel number be the one you set here. And then once that port channel is created, you're actually going to go into that interface and set up that layer 2 Ether channel to be a trunk, if that's what you want to do. And then notice we're talking Ether channel here. And when we run our Ether channel commands, it creates a port channel on the CLI, right? And then if you come over here to our show command, when we want to look at that Ether channel or port channel, the command is show Ether channel summary. So remember I was telling you port channel and Ether channel are two terms that we're going to interchange in Cisco. So sometimes you're going to hear me saying Ether channel. Sometimes you're going to hear me saying port channel. That mean the same thing. And then for some commands like this verification and configuration commands here, they're actually very specific. You have to get into the port channel sub-interface configuration mode to configure your Ether channel. And this is going to be the same whether it's PAGP, LACP, or static. So in LACP, its two modes are active and passive, and it's going to follow the same logic. Active is going to place that port into an active negotiating state. So that port or those member interfaces are going to initiate the negotiation. And then passive is going to place that port into a passive negotiation state, which means it's not going to initiate or send those negotiations to the other side. So we have the same chart again, active, active, yes, active, passive, yes, passive, passive, no. You're not going to form. Just like PAGP, same logic. Okay, and then LACP is configured the exact same way. Check it out. The only thing different is that active command is now placed as the mode. And another thing about this channel group number, guys, it does have to match on both sides. It's part of that negotiation. It's part of that formation of the Ether channel. Both sides have to agree on a Ether channel or port channel number. Okay. And then static. There's only one mode for static, and that's mode on. So on this slide, we're also going to break down that Ether channel summary command. So with the Ether channel summary command, it's going to show us a couple different things. It's going to show us which member interfaces we're trying to bundle. And then it's going to have these flags here. And these flags are going to tell us essentially whether or not we're layer 2 or 3, and if we're in use or we're down. Okay? So capital D here, if we see that flag under this port channel column, that means our Ether channel is not working. It means one of the member interfaces is in the wrong mode. We can't actively negotiate with the other side, or we're suspended, right? Or, yeah, we're just down. And then we have this lowercase s, which stands for suspend, which also essentially means you're down. The Ether channel is not working. And then we have the capital P here. That capital P is going to say that we are bundled and that we are actively sending traffic on our Ether channel. So sometimes you'll see a case where 3 of your member interfaces will be bundled, and then 1 will be D or S for suspended. And essentially what that's saying is, okay, well, some of your member interfaces are actively sending data across their wires, but the other one is in suspend mode or down. So you have to go fix that. So we want that P flag next to these member interfaces. That means we're good to go. And then this U means in use, saying the port channel itself is being used, right? And then capital R is stands for layer 3, capital S stands for layer 2. So what you're going to see here on the member interfaces, actually, guys, is if they're not bundled, you're going to see that lowercase s. And then if the whole port channel is down or in use, that's when you're going to see the capital U or capital D under this column. So you won't see that capital D over here in the ports. You'll only see it under this port channel column. Okay, and then layer 3. So this slide's very simple. You can also configure layer 3. Essentially, it's the same steps, except you just have to make sure that you're using layer 3 interface. So on a switch, that is possible. And in our Etherchannel 2 lab, I'm going to show you how to create a layer 3 Etherchannel between two multi-layer switches. Okay, awesome. Thank you for viewing this lecture, and stay tuned with us as we go over our Etherchannel lab. Thank you.